So every housing has some unique features. One is a pry slot on the edge, which helps separate the cap from the base. The housing and bearing are actually centered, so there's a mark at the end of the housing and it's centered where the bearing, so it will be easy to locate and position the bearing on the shaft. The bearing itself can float within the housing, and you saw that earlier when we used the fixing ring to lock it in place. If I remove the bearing and look at the housing a little closer, in each seal groove is an oil relief channel. So if oil collects in the seals on an oil lubricated bearing, it can drain back into the bearing, sort of into the sump. At the bottom of each housing is a drain plug, so this can be removed and let oil drain out, and actually put a sight glass on there if necessary. But under each bearing seat is an oil channel, so it allows the oil to balance on both sides, so both sets of rollers of the spherical bearing can be properly lubricated. The housing itself has a solid base, so heavy capability. The cap has a pad on top that can hold a nameplate or even be serialized with a part number that's convenient for you or the end customer. And on each nameplate, we could provide a thermal strip, which allows you to monitor temperature of the bearing just at a quick glance. When mounting a spherical bearing, it's important to understand the clearance and what clearance will be removed. So internal clearance is important to measure before you start, and the instruction manual would say for this size of bearing, there's roughly 4 to 5.5 thousandths of internal clearance between the roller and the outer race. When I'm setting on the table, the clearance is at the top of the bearing. If it's hanging on the shaft, the clearance drops to the bottom. So easy enough to measure underneath the roller. You may have to press the roller in a little bit to be able to slide underneath, or lift the outer ring up slightly and you can pass the feeler gauge across the top. For larger units, this is not simple because the weight of the bearing gets heavier. So a band can be brought around and you actually lift up to be able to create that easier place to check the clearance. But this is an extremely important part of mounting the bearing. So again, measure initial clearance, document it, and as we go through the tightening process, we will take clearance out little by little, and that will allow you to measure along the way during that process. And the instruction manual will provide the details of how much clearance to remove. But in general, you will remove about half of the internal running clearance. So during the installation of the two bearings, it's going to be important to determine the fixed and the float. So on every shaft, there is one of each. I've mocked up the assembly of the two seals and the bearing and adapter sitting in the housing. And you can see there is a gap between the side of the bearing and the housing. So that would be the way the bearing would float inside the housing for shaft expansion due to thermal change. But we also have to install a fixing ring on one of them, and that fits next to the bearing into the gap, so the bearing is actually fixed in the housing when it's assembled and mounted to the shaft. The assembly of the SAF will entail taking the seal that's going to be positioned inboard and putting it in place. Next will be placing the adapter sleeve on the shaft, and we recommend a light coating of oil on the shaft. Not heavy, but just something to protect the shaft, keep it from rusting. The bearing then can be positioned on the tapered adapter and slide it up as far as it will slide. The assembly allows for the tang to fit inside the adapter, and that will become important when we lock the adapter in place or lock the nut in place. And then last is the nut. And we will use this nut to tighten the bearing onto the shaft further. So with the bearing situated on the adapter, I'm going to remove the lock washer for right now and tighten the nut on the shaft without the use of the locking washer. After it's fully assembled, we will put this back in place and make sure we're able to lock the nut down. We just don't want the washer to get in the way of our wrenches and tools. So the nut can be threaded onto the adapter. And we'd like to get that adapter as tight as possible so it doesn't move. Once it starts to tighten, it will actually squeeze onto the shaft because it's forcing the tapered sleeve through the inner part of the bearing, locking and squeezing it down, essentially developing a press fit. So we would suggest a spanner wrench and a mallet to start tightening the adapter nut in place. Right now the sleeve is just a little bit loose and I need it to lock up. So during the tightening process, this is important in order to get the adapter very tight. As the nut is tightened, you're going to periodically measure that clearance again. I'm lifting up slightly to get the feeler gauge to pass. And we do not want to roll the gauge over the roller. It's not important to do that. In fact, you'd get a false reading. So every few hits of the mallet, continue to measure that clearance until we reach the final recommended clearance that's listed in the instruction manual. For bearings this size, a mallet and spanner wrench are quite normal. As the bearings get a little bit larger, it will become a lot more difficult to install that way. We'll talk about some other methods here in just a minute. Using a drift and a mallet against the slots is a method I've seen used. I'd recommend against it only because it allows metal chips possibly to come off of the nut and maybe lodge internal to the bearing. So keeping it as clean and as void of metal shavings is certainly important for the life of the bearing. And the final result then is measuring that internal clearance and said, okay, I've achieved the clearance that the instruction manual has suggested. And remember, I'm lifting up on the outer race here, so it does pass. Otherwise, I'd have to measure at the bottom. Either place is okay, but just know where the clearance went. So the lock nut now is tight. We're happy with the final internal clearance that the manual suggests. Now we'll remove the nut. Install the locking washer so the internal tang will fit in the slot. We will tighten the nut until it seats and tighten it a little bit further so we can bend that tang into position. So it'd be as simple as taking that tang and knocking it into place, and that will lock the adapter nut to the adapter so the bearing cannot come loose. So once all assembled, we'll put the last seal in place and drop it within the housing. So bearing assembled, ready for the fixing ring. And now we can lubricate the bearing. At this point, the bearing is fully